Next, let's do example 9. But before that, I want to point out that these equations, again, I rewrote them from the last video because I feel like that lines up better. Okay, specifically, remember that the definition of logarithm, log by equal to x, means b to the power x has to be y like this. Okay, so as a result of that, b of log by equals to, what does that equal to? Well, as we have said here, x is log by. So this is x, and b to the x is y. So these are the same equations. And similarly here, b to the x is y. So what is log b of b to the x? Well, remembering that b to the x is y, so if you put y in here, this is the same equation, right? So therefore, it equals to x. As a result, b raised to the log b will give you the same answer as what's on top, okay? And log b of something is that thing itself. Specifically, natural log, which is base e, so it's like log e and e of x is x. And this is the equation we will use to get rid of the e whenever it's in an equation to solve for x. And okay, so that is, and one more thing is log b of b equals to 1. And these are our old formulas, okay, that I won't mention it right now, but you can glance at it quickly to refresh your memory. The thing about logarithm is that they are easy to learn, but also easy to forget, okay? So so constantly refer back when you forgot it was plus, minus, who knows. And then, and this will clear it up. So let's, having said that, let's do example 9, which is supposed to solve this equation right here. Again, if you have trouble, any kind of trouble solving equations, or if you can't follow what I'm doing, please review section 2.2, examples 1 to 7, and 2.6, examples 1 to 11. Okay, just glance at them real quick. And if you have any problem, if there's any part that you struggle with, then work through them yourself, okay, and refresh your memory. So having said that, yeah, okay, so let's solve for this thing. And to solve this equation, anything that isn't directly connected to x, let's kick it to the other side of the equation. We have then we have 2 natural log of x equal to 7 minus 3 is 4, okay? Dividing both sides by 2, then natural log of x equal to 2. And so what's x then? To get rid of the natural log, we'll write down a e on the bottom, e, okay, because e and natural log, see, the base and the log of the base cancel out each other. It just equal to the item itself. Yeah. So this is equal to x, okay, that is e to the natural log of x is just x. And this side, it becomes e to the power squared, and so e squared should be the answer to x. And let's check if it's true. Yes, it is. So that's example 9. Next, let's look at example 10. Now we have a 2 up here. Okay, well, we'll just get rid of it by pushing it across the equal sign down to the bottom down here. Okay, so then we have natural log of 6 of x is equal to 7 over 2. 7 over 2. All right, and now we need to get rid of the natural log, and we'll do the same trick here. To get rid of a natural log, you'll write a giant E under it, E and E here. This E is to the entire power 7 over 2, okay, the whole number. And E and natural log will cancel out, okay, as I show here. And like E, pretend B is E, right? E to the power log base E, which is the natural log, is of some number, is the number itself. So then, so this thing, e to the natural log of 6x is 6x, okay? It cancels it out. That's how we get rid of the natural log. And this side, that stays, so this is e to the power 7 over 2. And then we'll divide it by 6 on both sides. So then this is e to the power 7 over 2 divided by 6. And whatever that is, that will be the right answer. Let's see, do we have the right answer? Yep, 1/6 e to the power 7 over 2. That's it. Okay, so next let's look at example 11. Now, in this one, we have a very simple problem, okay? Natural log of x equal to 3. So what is x? So as before, the way we solve anything with natural equation with natural log in it, it would write a giant E under it to get rid of the natural log. So we'll write this giant E right here, okay, under both sides. Gotta do it to both sides to be fair. And so that becomes x equal to, okay, because E and natural log cancels out, okay? So we have x left, and then this is e to the power 3. And that is the answer, okay? That's all it takes. However, what the book wants us to do is it wants us to graph this function and graph this function. That is, we're gonna graph y equal to natural log of x, the first graph, and then y equal to 3, and see where they intersect, because that is the answer of this equation. That is, they will intersect where x equal to e to the power 3. Okay, and yeah, so to graph that, then okay, so let's graph it. The natural log graph, it goes something like this. Okay, it dives down and go to, this is the asymptote. Okay, take a deep dive. And then this is 1, because normally natural log of 1 is always 0, okay? What am I saying? Yeah, that's right, because anything to the power 0 will be equal to 1. And anyway, so it crosses 1 as 0. And then we need to know when x equal to e to the power 3, that's something like, I don't know, maybe 25 or something, around 25, I mean. Anyway, this, let's say this is e to the power 3, wherever it is, and then y equal to 3. So here's 3. We'll draw y equal to 3 right here. Okay, so that is, here's the line y equal to 3, and this is the graph y equal to the natural log of x. And where they intersect, they should intersect at x equal to e to the power 3 and y equals to 3. And that's why this is the solution. The solution of two equations, one way to look at it is you graph both sides, okay, and see where they intersect. Okay, that is, so having said that, let's flip to the next page. Yeah, okay, e to the third is about 20. So that is, as you can see, the book graphed it and looks more or less like mine. Of course, the book's graph is much better looking. Other than that, that's about that. The next point is we consider something called the one-to-one property of the natural log. The point is that, let's see, where is it? Let's look at, what does that mean? Okay, let's look at the following page and look at example 12. All right, example 12, we are supposed to solve this problem. Your book, however, also mentions something about one-to-one. Basically, what that says is that for these two, you see, we have natural log on both sides, right? For them to be equal, and we need to find x, what's inside the natural log had better be equal. That's basically what we're talking about here. So in other words, if we can find x such that these two are equal, then slapping natural log on two equal things, they'll be equal at the same time. Yeah, that's good enough for now. So let's solve this thing, being that these are natural logs, right? And everything's the same. So we'll just make sure that what's inside is the same. So then we have to solve x squared equal to 2x plus 3. Now that will solve into, let's do that, okay? This is equal to x squared minus 2x minus 3 equal to 0. And that would be, that's the quadratic equation. Right. Please review how to do this, okay? This is done all the time, so you do need to know how to do this really, really well. That's a minus 3 to become minus 2. That's minus 3 plus 1 is minus 2. And that's about it. So then x equal to minus 1 or x equal to positive 3 equal to 0. So that gives us x plus 1 is 0, which is x is minus 1. X minus 3 is 0, x equal to positive 3. All right. If that is the case, we have All right, so let's, when we have this kind of stuff, it's a good idea to plug it in to see if it works. Because sometimes you might crank out some garbage that doesn't work. And even if you didn't make a mistake, it's possible, okay? So it doesn't hurt to plug it in quickly and see if it works. So if x is minus 1, that becomes natural log of 1. Natural log of 1 is 0, okay? But any log of 1 is 0. So that's 0, all right? So natural log of, what's this side? 2x plus 3 is also 1. So that's also 0. That's fine. This one, natural log of 3, well, yeah, that's 9. Okay, this is 2 times 3, 6 plus 9. That's natural log of 9 equal to natural log of 9. That's fine. So we're good. Yeah, actually, so that's right. And that is what the book says as well. And that is, so that's that, okay? And the next problem, example 13, we're going to skip it because that's a word problem. And the word problems, radioactive decay, and plus a whole ton of other stuff will be discussed in detail in the very next section. So we're going to skip it for now. And then, and that marks the end of this section. So please do the homework, okay? For homework, please do 37, 39, 41, 43, 45, 47, 49, 55, 57, 69, 61, 63, 71, 73, and 75. And when you're done, I want to talk about some of them. I just noticed that I forgot to cover the homework for part A in the previous video. So let's do that first, okay? The previous video's homework is problem 5, 7, 9, 11, 13, 15, 17, 19, 23, 25, 27, 29, 31, 33, and 35. And I will, hopefully you have finished that homework from the previous video. If you haven't done so, please do so right now, okay? And then when you come back, I will cover them. Okay, let's go to problem 7, okay? This is homework from part A. Okay, so let's see, to do this thing, okay, let's, well, we'll follow the exponent rules, which are these things right here. Okay, so let's do that. So first we will say that 2 to the power minus 3, 2 to the power minus 3n, okay, times 2 to the power minus 2, okay. The negative power just means you put the number under the division line. That's all there is to it. And then that equals to the same thing here. That doesn't change. And next, when you have the same base, see there's 2 and 2 right here, you can add up the exponents and write it under one base, like this, okay? And to add a negative number, you just, it's the same as just the negative number, 3n minus 2. And that follows this plan right here, okay? When you have the same base, then the powers can just be added up under this, just one base only, like this. So that equal to 2 to the power n plus 2. Now, being that the base is the same, that means the exponents has to be the same for the equation to hold. So then we have minus 3n minus 2 equal to n plus 2. And then so that is going to be equal to, we'll move the minus 3n on this side. And then that becomes 4n, right? 3 plus 1. And this side is equal to minus 4, okay? Move the minus 2 to this side, becomes negative. And then so n will be equal to negative 1, which is correct. So that's, so far so good for problem 7. Next, let's do problem 9. Problem 9, we start out with these fairly big numbers. That's even bigger. So, but luckily, these two are the same number. Now, when the base is the same, then remember, anything under the division line is the same as having a negative exponent. Okay, so we have, so this side is the same as 36, okay, time to the power 3b minus 2b. Okay, because the 2b is negative if you move it back to on top. And so that equal to, we'll write this down as is, okay, 16 2 minus b. Okay, so then, but we need to change this thing. What is this thing? Is, well, it's not obvious to me how this relates to 36, and we have to make the bases the same, okay? Because if the bases are not the same, then we can't compare them. So then So then let's do that. We'll factor the whole thing out. What is 36? To factor out 36, we'll write it over here, okay? 36 is 4 times 9, right? Which is 2 times 3. Yeah, 4 times 9 is 36, which is 2 squared, okay? And then 3 squared, all right? And everything is to the power of 3b minus 2b, that's just b, 1b. All right, and then 216 divided by 3. Now remember, if you add up all the digits, 2 plus 1 plus 6, that's 9, that's divisible by 3. That means this number is divisible by 3. So what is the factor of 216? We can do this on the calculator or in your head, either way, okay? So let's divide it by 3. That's 3 times 21 divided by 3 is 7, and then 2. That's 3 times 72, which is equal to, let's see, divide by this by 2, okay, which is equal to, let's see. So 3 will factor out another 2 out of here, times 2 times 36, okay? And so 3 times 2 times 36, we already got that 36 is 4 times 9, times 2 squared, times 3 squared. And that together equals to 216. 216. And we need to, so what is that? That together means 3 to the power 3. And then 3 to the power 3 and 2 to the power 3. 2 to the power 3. And the whole thing is being raised to the power 2 minus b. 2 minus b. All right. So we got that thing. And so that equals to, all right, we will, let's see, we'll round up this thing as, to make it the same base, we have 2 times 3 in both cases, okay? So this is the same as 2 times 3, 2 times 3 to the power 2b, okay? And then because the 2 comes out to be, because when you multiply this out, the 2b will go on 2 and on 3. Yeah. Right. Is that one? That's not one of the rules I've written down. Let me think. Maybe I should write that down. Let me write that down. All right, here's one of the rules from chapter 1, the review chapter. Again, please review this if you feel anything in any way rusty about it. So when you have a product raised to the some power, that's the same as the power going over each thing. Okay, so that is what I'm doing here. Is when this is when you calculate this thing, this is the same as that, because the 2 will then go on each item that's being multiplied together. See, that's the principle I'm going by. Okay, so that is similarly on this side, this 2 and 3 are both to the same power. That's the same as 2 times 3 to the power 3 times 2 minus b. Now notice this, the 3 has to multiply by the entire expression here, which is 2 minus b, so you got to put it in parentheses. Okay, so now finally we have come to the point where the base is the same, so now we can solve the exponent equation, which is 2b equal to 3 times 2 minus b, and that should be equal to, so that's 6 minus 3b, right? And 2b is still here. Move it over here. So that's 5b equal to 6, and b will be equal to 6 over 5. And that should be the right answer. Let me check. Yep. The answer says, at the back of the book says 6 over 5. I'm right. Now, the only tricky part about this problem is, first you have to factor, right? And second, you have to remember this particular rule. that the 2, if they both share it, then it can come out over here. And if it go back in, then it has to go on each one, see? And this is the same as this thing. And similarly, when you take the 3 out of the parentheses, then it's over here being multiplied by this other stuff. And this is the only, and all this is covered in chapter 1, the exponent part. Again, please review this thing, okay, all these things and this, if any of it feels rusty. So next, let's look at problem 15. So problem 15, we have minus 8 times 10 to the power p plus 7 minus 7 equal to negative 24. All right, so let's, we'll need to solve for p. Now, you might ask, why isn't there an x there? Why is it p? We'll call it xp. What's the difference, right? One is as good as another. So we're going to solve for p. And to do that, first we'll kick this minus 7 to the other side. Then we're going to push the 8 underneath, the negative 8 underneath. From doing that, we get 10p plus 7 is going to be minus 24 plus 7. That is, what, 17, right? Negative 17. And then divided by minus 8. Divided by minus 8, and that's, well, I don't need another. That is just... that we have 2 minus signs. Let's cancel those out. So we have this. So then, okay. And so next, now what? Now we will take the log base 10 on both sides. On this principle, where's the principle? Yes. If we have 10 to the power, let's see, where do I have that? Yeah. Right here, okay, we have b equals to 10 in this case. We have b to the power x, and we need to get rid of this 10 because it's raising our variables in the power, and we need to rescue it out of there. So to do that, we'll slap a log against it, okay? So we'll write down log base 10, being that this is 10, b has to be 10, and so let's write it down. If the log base 10, you don't have to write down 10, okay? It's understood to be 10. We'll write down log here. Log base 10 of that whole thing. Here's a parentheses that's squeezed in there. Okay, so if we write down log base 10, this cancels out the base 10. So we have only p plus 7 left. P plus 7 is equal to log of all this, log of 17 divided by 8. And that should be the answer. What problem is this? 15, let me check. Is that right? It has a minus. Why does it say minus 7? Let me check. Did I? Oh yeah, p plus 7. I'm not done yet, right? So then p is equal to this thing minus 7. Duh. That's true. Okay, your book is right. So that will be the answer. Okay, so p is whatever this is, minus 7. Throw the plus 7 to the other side of the equation, and that is your answer. Next, let's look at problem 19. Negative 6e to the power 9x plus 8 plus 2 equals to negative 74. Okay, so let's fix this thing. The first thing we do is anything that's not directly related to x, you know, there's a plus 2, let's kick it to the other side of the equation. And next step is when things are being multiplied, a number multiplied, let's push it down across the equal sign to the bottom. Okay, by doing that cross multiplication trick. So if we do that, then we get 9x plus 8, that part stays for now. 9 equal to minus 74 minus 2, okay, that's minus 76. Minus 76 divided by the minus 6 here, minus 6. So that minuses cancel out, so we got here. And 76 is, well, is 76. And anyway, we'll leave that for now. And the next step is we need to get rid of the e. To get rid of e, we need the natural log, okay? The natural log of e will cancel themselves out so that you got only what's on top left, like this equation shows. So let's do that. And slap the natural log on both sides of the equation. Natural log of all this stuff, okay? Natural log of all this stuff, like that. And then we have, so then we natural log and e cancels out, so we have just 9x plus 8 left. And this side stays, is natural log of 76 over 6. We'll deal with it later. So this equal to, now we need to solve for x, okay? And this looks complicated, but we don't really care right now. It's a number. If we use the calculator and do all this, then it will spit out a number at us, okay? We don't know what it is right now, but we know it's a number. So we'll just treat it like some number. And so we need to solve for x. X will be natural log, copy this down for now. 76 divided by 6. Minus 8 first, right? Let's push the 8 to the other side and then do the division. The division, push 9 down. Remember, 9 has to go under all of the stuff, okay? Not just the first thing item, the whole thing. And that is the answer. Let me see. This is problem 19. Checking the answer at the back of the book. They did simplify this thing into 38 over 3, which is fine, and minus 8 over 9. Otherwise, this is correct. Okay, and that is all we're gonna do. But don't forget. Well, simplify that. I guess I should have done that before, but that's not of critical importance. So anyway, let's see. Next, let's look at problem 29. All right, now problem 29, we have log base 10 of 1 over 100 equal to -2. It says that use the definition of a logarithm to rewrite the equation as an exponential function. What's that supposed to mean? That means we need to go let's see, from here to here. That is, we have this equation right here where b is 10, right? And y is 1 over 100 equal to x is minus 2. We need to rewrite it like this. So to do that, that means 10, okay, down here, 10 raised to the power -2 is going to be equal. So that's b raised to the power x. This is the x in the equation. This is the y in the equation. Okay, and this is the b in the equation. So we write it the other way, will be b to the x equal to y. So b 10 to the x minus 2 equal to y is 1 over 100. And that is the answer. All right, so next. Let's look at problem 31. We have 5 times log 7 times n equals to 10. Okay, so then to solve for n, again, n is like the new x in this problem, okay? And so to solve for n, we will first divide the 5 over here. So we have log base 7 of n equals to 10 divided by 5, which is 2, okay? Now that is, next we're gonna solve for n. We'll go do it by the definition of log. Log by equal to x means b to the power x equal to y, it says right here, okay? In other words, 7 to the power 2 equals to n. So n equals to 7 to the power 2. In other words, n is 49, and that should be our answer for problem 31. Yep, that is correct. Next, let's look at problem 33, which says 4 plus log 2 9k equals to 2. Okay, all right, so that is our variable. Now the variable is k. We don't care what it is. K is now the new x, and we'll solve for it. And so get rid of any number that isn't related. Kick it to the other side, okay? So then the logarithm is log 2 9k is going to be equal to minus 2, right? 2 minus 4. Okay, so that means, based on this definition right here, what does this mean? Okay, log 2 9k is minus 2 means b to the power x equal to y, says right here. In other words, 2 to the power minus 2 has to be equal to 9k. So 2 to the power minus 2 equals to 9k. Okay, yeah? And then, so we'll solve for k. And what is 2 to the minus 2? That's 1/4, okay? According to this rule. Any kind of negative power, you just sink it to the bottom of the division line. And so then 9k, then k equals to, push the 9 across down here, is 1 over 4 times 9, 36. That should be k. And that's for problem 33. Let me look at the answer. That looks correct. So next, let's look at this. what is that? Problem 35. 10 minus 4 times natural log 9 minus 8x equal to 6. All right. Now to do that, we have, let's get rid of the 10, kick it to the other side, okay? And then push the minus 4 across the equal sign to the bottom of the division line. So after we do all that, then we will have natural log of 9 minus 8x equal to 6 minus 10, okay, which is minus 4, divided by the minus 4 here. Okay, so that's just 1. So that's convenient. The natural log of something equal to 1, okay, let's see, that means natural log is the same as log base of e. So e to the 1 power equals to 9 minus 8x. So we'll write that down. In other words, well, let's write that down, okay? That is the base b to the power x equals to what's inside. It says right here, okay? So e to the power 1, which is just e, equals to what's inside is 9 minus 8x. So to solve that equation, then we have e to the 1 is just e. We'll move the 9 to this side. It becomes e minus 9 divided by, so x equals, move the 9 over, push the minus 8 across the equal sign to down below the division line. So that is the answer to x. Now to, what problem is that? 35. Let me check. X equal to 9 minus e over 8. That's correct. Now the answer in the book flipped it around and turned this sign into positive. That's fine too. Okay, either one is acceptable. Although most people probably will switch the 9, flip this around, it becomes 9 minus e, okay? It's a negative 9 minus e on top here, divided by minus 8, and then they cancel it out. That way you don't have a negative sign there, because people don't like negative signs, okay? The positive signs look much more positive and nicer. But otherwise, it's the same answer. Either one is acceptable. So now we have finally come to the problems in part B. Now next time I'll remember to do the homework for part A in the video for part A. Okay, this, yeah, anyway, I won't make this mistake again. So, anyway, so problem 41, we have this thing right here, which is what? Natural log x minus, what? I think I copied down the wrong problem. Give me a moment here. Okay, problem 41, natural log of x minus 2 minus natural log of x equal to natural log of 54. That looks about right, okay? And so let's do that. Now this problem, compared to the ones we did previously, we just had some kind of a number here that we can kick it to the other side. But now we have x appearing in 2 places. So we cannot just kick it to the other side, because that's, we need to round up these 2 things together. So we're gonna do that by the trick of, well, by combining them, okay? Something that we learned in the previous section, how to combine this thing so that all the x's are at the same spot. So to combine it, subtraction means division, right? We're going to apply this rule right here, where, or put it this way, a subtraction here, subtracted log, is the same as log of c over d. So let's applying that rule, we have natural log of x minus 2 minus 2 divided by x, okay? So see, this will translate into that if you break them apart, applying this rule right here. So then this will be equal to the natural log of 54. So now we have something inside natural log, okay? In the same, it is equal with the same log here, which means what's inside has to be equal. So then we can just ignore the natural logs. Yeah, so I'll write that down again. So x minus 2 over x will be equal to 54. Basically, the natural logs cancel out because they're in the same, they are identically on both sides. So what's on inside had to be the same. And then now we are left with solving this equation from chapter 2, right? And so let's do that. We have then x minus 2 equal to 54x. So then we'll put the x on this side. That will become this becomes minus, right? So it becomes 53x equal to negative 2, which means x will be equal to minus 2 over 53, which is that the right answer? Let me check. 41, no solution. All right, let me think about this. Right, the reason is because I haven't plugged this back in to take a look to see if it even works. Now, if you plug the x as a negative number, okay, into here, that's going to crash because the natural log or any log is not defined for negative numbers. Okay, any log will only take log of positive numbers. You know, a graph of log looks like that. Only on this side. There's nothing on this side. So if x is negative, then it has to be rejected. Okay, so this thing is, we'll call it rejected. Okay, reject. And therefore, there's no solution. And that the answer is that there is no answer. And that's the answer to this problem. Next. So next, let's look at problem 43, natural log of x squared minus 10 plus natural log of 9, and that equals the natural log of 10. Okay, there's no x here, so that's good. We'll kick it to the other side, okay, and then think about it later. So let's do that. Kick that over. We have natural log of x squared minus 10, okay, equal to ln 9 plus ln 10. Now, what is ln? Now, ln 9 plus ln 10, we can combine it. This is equal to ln of 90, 9 times 10, following this rule right here, okay? And that would be, which means that, see, we have a natural log of, on both sides, right, of something equals the natural log of something else, which means what's inside had better be equal. So knowing that, then we have, so x squared minus 10 equal to 90. And we just need to solve this equation, then we are good to go. Now, what is that? That is, so kick this to the other side, becomes plus. Then x squared is 90 plus 10 is 100, which means x is, if x squared is 100, x is equal to plus minus 10. Okay, so that will work. Both answers will work because when you plug it in, x is being squared. So it's going to be 100 minus 10 is 90. Okay, 90, wait a second. Is that right? Let me check this for a second. Yeah, I knew that didn't look quite right. I messed up. See, right here. Okay, when we kick this plus 9 over there, it should turn into minus, right? I forgot. So this is minus. That really matters because that's now is a negative. This means natural log 10 minus natural log of 9. So instead of multiply, it's dividing. Okay, so let's change that. Fix it. Let's fix this problem. This is natural log of 10 over 9. So this does not equal to any such thing. Let me erase all this stuff. Actually, I'll just erase it. You can just watch me erase this thing. All right, this is minus. Okay, so this is 10 divided by 9, right? Following the division rule right here. So the positive, the one that's positive, so divided by the one that's negative. So 10 divided by 9, which means this thing equals to 10 over 9. Right. All right. Is that right? Let me check to make sure that I'm right this time. It doesn't matter. I'll just see if I'm right. Okay. So then we'll multiply both sides by 9 so that we have 9x squared. 9x squared minus 90 equal to 10. Then then okay, now it should look okay. So then to do this, kick this thing over there. That becomes plus 90. So this is 100, right? 10 plus 90 is 100. And then we have 9x squared left on this side. So then x squared, push the 9 across the equal sign to the bottom of this thing. X squared will be 100 over 9. So x then equal to the plus or minus the square root of that thing, which happens to be 10 over 3. And that should plug in here just fine because we're being squared. So being squared, that will be Let me see, does that work out? Let's plug it in to see if it actually works. Actually, it's fine. Okay, as long as it's defined, that's all we care about. This is the right answer, so we'll accept it and move on. Okay, and not work ourselves to death. So that's problem 43. Next, let's have problem 47. Let me write it down. Okay, problem 47 says natural log of 7 plus natural log of 2 minus 4x squared equals the natural log of 14. Okay, so let's do that. Now this time, the x only shows up in one spot, so we can kick everything else to the other side. Doesn't matter what it says. So then we have natural log of, okay, so we have natural log of 2 minus 4x, write that down. We have that equals to natural log 14 minus natural log of 7. Okay, minus translates into division. We'll write it that way. So that's natural log of 14 minus 7. That is a 4. Let me fix that. 4 please. 4. Which is, of course, 2. But we'll think about it a little later. Okay, so that would mean that what's inside has to be the same because our problem set up. See, the natural log of something equals the natural log of something, so that those two somethings had to be the same thing. So, so we can get rid of the natural log and just have solve the equation 2 minus 4x squared equal to 14 over 7 is 2. And so we have 2 on both sides. Now that means x equal to 0. Okay, because get rid of the 2 for x squared equal to 0, that's x will be 0. And let's see. Okay, so let's see what happens when x is 0. Everything's fine. The natural log is defined, and natural 2, well, whatever. So 0 should be the right answer. Let's check. Yep, the answer is x equal to 0. Next, let's look at problem 49, which says, okay, natural log of 3 minus natural log of 3 minus 3x equal to natural log of 4. Okay, now this time, again, x only appears in one spot, which means we can kick all this thing to the other side. Okay, so let's do that. And we have, therefore, upon kicking, did I dry this up? Okay. So we have minus natural log of 3 minus 3x, and that equal to natural log of 4 minus natural log of 3. Okay, and that is the same as 4 divided by 3 by the division rule. You see, if you have log of c minus log of d, that's the same as log of c over d. So that's what I have right here, because that over here will become a minus. Okay, so that would normally mean that this is equal to that. However, there's a negative sign here that we cannot ignore. And then we have to make sure that there's no negative sign, because there's no negative sign on this side. And how we're going to do that? Then what we're going to do is the negative sign is the same as -1, right? This is -1 times whatever. And we are going to get rid of it by moving it up using this rule right here. Kick it on top, okay, of the logarithm. So this equation then equal to the natural log of 3 minus 3x to the power -1. So now it's positive, see? And that again equal to that thing right there, okay? And then so then what we get is this thing is going to be equal to what's in here. 4 over 3. Now what is this thing? This thing, the minus power, is the same as 1 over the thing with the positive power. In other words, this is the same as 1 over 3 minus 3x, like this. All right, so so that equals 4 over 3. Okay, and then so next, how are we going to do that? We're going to do something called cross multiplication. Again, please review chapter 2 on solving rational equations if you have a problem. So, but to do that, in this case, you can just cross multiply. Remember the cross multiply? Anyway, so 4 times that equals to 1 times that. And so we have 4 times 3 minus 3x equal to 3 times 1, which is 3. So now let's solve this thing, okay? We'll write down the equal sign, kick the 3 to the other side over here to become -3. and then 4 times 3 is 12, so it's plus 12, okay? And then this minus 3 times 4 is also 12, but it's negative. We'll move it to over here, becomes positive. It's positive 12. Yeah, I always like to keep my x's positive, okay? No reason, it's just cuter that way. And anyway, so we have this, and this side then equal to 12 minus 3 is, what's 8, right? So 8, so then that gives us x equal to 8 divided by 12, okay, which is 2 over 3, once you cancel out the 4 in it. So that should be the right answer. And what problem is that? 49. All right, let me check with the answer at the back of the book. No, the answer is wrong. Let me check to see where I make a mistake. I probably messed up somewhere. Okay, I found my mistake, which I'm sure you already know, right? What is 12 minus 3, for heaven's sake? It is not 8. It is 12 minus 3 is 9, right? So this is equal to, instead of 8, it's 9. So if it's 9, then it's 9 over 12, which is not 2/3, heaven's sake, it is 3/4, which is the right answer. All right, so anyway, that should be this, that should be that. Okay, that's for next. So next, let's look at problem 59. Okay, let me write it down. I forgot to write it down. Okay, next, let's look at problem 59. Which says log base 11 of negative 2x squared minus 7x equal to log base 11 x minus 2. All right, so let's work on that. And when you take a look at this thing and you're thinking, we have log base 11 on both sides, right? So and there's no negative sign, nothing weird happening. In other words, what's in here needs to be equal. It's that simple. We can just cancel out log base 11 on both sides of the equation. So that equal to minus 2x squared minus 7x, that equal to x minus 2. So this is called a quadratic equation. You don't need to write the parentheses here because, yeah, it's not necessary here. But anyway, just so let's solve this quadratic equation, which is taught in chapter 2 if you don't remember how it's done. Okay, and so I will do that. That equals to I like to put this x squared positive. Okay, we'll move it to the other side. Becomes positive 2x squared. Okay, minus 7 move over here, becomes positive 7 plus 1 positive 8. And then minus 2 is still here, and then this equal to 0. And now we have to do that thing again. But this number is 2, which makes it harder to do. Oh well, give me a second here. I need to. All right, so let's rewrite this. There's a bunch of 2's here, so if I didn't mess up, so we can cancel it to be just 1. So x squared plus 4x minus 1. That does not look good at all. Let me check to see if I messed up. Now, when I say that it doesn't look good, I'm just saying that there's no short way of factoring this thing. And we have to go to that thing that's called quadratic formula. Now, remember what the quadratic formula is? If you have forgotten, please memorize it right now. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a, where this is a, this number here, 1 is a, b is 4, and c is negative 1. Okay, so please look it up and memorize it if you haven't done, if you have sort of lost it after this time. And let's see. So let's do the quadratic formula. What can I say? Okay, so the quadratic formula states that x equals to minus b plus or minus square root of b squared. B is 4. Okay, b squared minus 4 times a is 1 and c is minus 1, so we need to write that down. All over 2 times, 2. Let me think about this for a second, okay? All right, so I typed this into the Desmos calculator because in this problem, we're also supposed to plot this graph, That is, we're supposed to plot y equal to this left side and also y equal to the right side, and then look at the Desmos calculator and see where the two graphs intersect to find the solution. So I typed this thing into the Desmos calculator, okay, and it gave me the answer right away. See, this is the by using a quadratic formula, we got this thing, which is the positive one, okay, the plus 1, and this is the minus 1. As you can see, the plus 1 is 0.23 or so. We'll just call it 0.2. And let's write that down. So x equal to 0.2, or what was the other one? Negative 4 point something. We'll just call it negative 4. Now, the reason we don't care to go too far is because if x equal to 0.2, you plug it in here, minus 2 is still a negative number, and logarithm does not accept negative numbers, okay? As I see, I erased that graph, but logarithm will not take negative numbers. So this is out. This is most definitely out. If it's negative 4, it's even more negative, and logarithm of any base does not accept negative numbers as a function. So the answer to this problem is that there are no solution. However, we are supposed to plot this thing out, right? So that's what I did right here in the Desmos calculator. I typed both equations in. That is, the first one is y equal to log base 11, blah, 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 right? The second one is y equal to log base 11, that. Now, there is no way to type in log base 11, but remember this formula, okay? If it's some odd base, you can just type in log of just type in ln or log of what's up here divided by a fraction of log of the base. See, keep that at the bottom, then that's the same thing. And that's how you type logarithm of any base that's not 10 or e into the calculator. So see, that is what I did. See, first, so I have it divided by log 11 because we're doing log base 11, and then this thing is the same deal. So once you type it in, that's the red graph, see, the red one, and then there's the blue graph. This is the left side equation, that's the right side equation, and as you can see, the two graphs don't meet. It just is. And well, the green line I drew here, that's just one of the roots. As you can see, it's not going to intersect the red line or the blue line because they both gone very, very vertical. They're not actually vertical, it's just that they dive down so fast that as far as we can see, they're vertical, okay? Because they are practically vertical is what I mean. So that is why the problem of 59 doesn't have a solution. So please be sure that you type this in the Desmos calculator yourself so that you know how to type stuff into the calculator, bearing in mind this equation when it comes to typing in log that's base that's not 10 or e. All right, so next. Actually, I'm running out of time, so I will finish this section. Even though we only have a couple of problems left, I'll finish it in the next video.